Okay, moving to the third exercise. Now we have a different sequence or discrete time signal. Okay. Now, as we did before, let us redefine the unit step function and use that definition to simplify the summation. So u of n plus 5, okay, you can write it in a straightforward manner, right? But let us take it easy now. N plus 5 greater than or equal 0, and 0 and n plus 5. So this is n. Okay, let me write it in a clear way. N plus 5 less than 0. So we have 1 when n is greater than minus 5, greater than or equal minus 5, 0 otherwise. Okay, so we use it here. So the counter starts from minus 5. We use the same tricks as before, right? We started from a negative counter, so we just add the negative terms until we start from 0. So we have this part now from minus 5 till minus 1, okay, and then we have the infinite series from 0 to infinity. Okay, as you can see, this is a finite geometric series and this is an infinite geometric series. Okay, okay, so here we need just to do some substitution of variables here, right? We should start from minus 5 till minus 1, right? Then we can just use here a substitution of m equals minus n like we did before, right? So when we do that, we arrive here. See, what we have done here is that this actually, let me write it down. This should be m starting from 1 till 5, right? And this 5 to the power 1 times z to the power minus 1 to the power minus m. Okay, we just change m by n here, and okay, we let's say flip this term, so the 5 becomes 1 over 5 and z to the power minus 1 becomes z. Okay, so this is what we have here. Okay, now we have a small detail that we need to attend to. This series starts from 1, not 0, so we cannot use the definition of the finite geometric series in a straightforward manner. We should modify it to start from 0. What we can do is that, okay, here can say that this series equals the series starting from 0 minus the 0th term. So let's call this y for convenience and say we have here that, okay, this equals a series starting from 0 ending at 5, y to the power n, okay, minus the 0th term. So meaning that I want to subtract out the term when n equals 0. So y to the power 0, this is 1. Okay, so this is what we have here. Now we use the definition of the infinite geometric series here and the finite geometric series here. Now we are just left with some serious algebra to simplify matters. We get to this term, right? As for the ROC, or region of convergence, what we need to attend to is just this first term. The second term is a finite geometric series and has a ROC of all the complex plane, so it doesn't really matter. So this term, right, sorry. So what we have here is that we say, okay, this should be less than 1, strictly, not less than equal, should be strictly less than 1. And of course, this means that, okay, I have 5 over z less than 1, meaning that I have absolute value of 5 less than absolute value of z, meaning that I have 1 absolute value of z is greater than 5, and of course by definition it's less than infinity.